Hey, hello and welcome to today's GFG problem of the day. Hope you're doing extremely well. So let's see today's problem, two swaps. Okay, so what the problem is saying is we'll be given a permutation of some of the first natural numbers in an array air. Okay, determine if the array can be sorted in exactly two swaps. A swap can involve the same pair of indices twice. Okay, so we have to return true if it is possible to sort the array with exactly two swaps. Otherwise, return false. Okay. So what the problem is saying is, for example, we'll be given an array which will contain the first n natural numbers. Okay, the first n natural numbers. So the natural numbers start with one basically. So natural numbers are what? 1, 2, 3, 4, 5, 6. So if the array size is 6, right? 0, 1, 2, for example. Okay, let me quickly. So if the array size is 6, so what will be the indices? 0, 1, 2, 3, 4, and 5. Okay. So okay. Now this array will contain the first six natural numbers, and they won't be sorted basically. So it can be like 4, 6, 1, right? 2, 5, and 3. It will be like this. Okay. So what we want to do is we want to find out whether this array can be sorted with exactly two swaps. Okay, with exactly two swaps. Okay. So that's what the ask is. That's what the ask is. For example, let's quickly see this example, right? 4, 3, 2, and 1, right? Now this can be swapped with exactly two swap counts. Okay, if you see here, right? So the first would be what? 2 to shift this 4 to 4 with 1, right? To replace 4 with 1. For example, 1, 3, 2, 4. So this is 1, right? And second is what? To move this, right? To replace this. Okay, or to swap this basically. 1, 2, 3, and 4. Okay, so you can see there are two swap counts. So yes, we'll return true basically. Okay, so that's what the ask is. We want to check out whether the array can be sorted with exactly two swaps. Okay, so that's what the ask is. Now, how can we solve this problem? Okay, now this problem will be solving using, okay, also the expected time complexity is what? The expected time complexity is O of n and space complexity is O of 1. Okay, now this problem will solve using cyclic sorting. So cyclic sorting, this comes into picture in such scenarios, right, wherein we have the first natural numbers. Okay, so if you see for example, what the problem is asking is, for example, if this is the example, right, 4, 3, 2, 1, right? Now what will be the sorted form? It is going to be 1, 2, 3, and 4. So if you see, so it should be, so r of I needs to be what? R of I needs to be I plus 1, right? R of I needs to be, for example, here, R of 0. So I is 0, right? I is 0 here. So 0 plus 1, 1. R of I needs to be 1. Okay. Okay. R of I here, if I is 1, that means this needs to be true basically. Okay. This needs to be true. R of I, which is, for example, I is 1, right? So R of I will be 2, which is equal to I plus 1. Okay. So in such cases wherein the expectation is that the uh, the array, the elements, for example, r of I needs to be I plus 1. In such cases, we can use cyclic sort. Okay, and this will work in O of n time complexity. Okay, so we are going to use cyclic sort. Okay. Uh, okay, so now let's see how can we use cyclic sort. Okay, so what we are going to do, simple, it's you'll understand better. So what we're going to do, for example, we'll start with the iteration. For example, here the indices, right? So we'll start with this first index. So here we'll check if it is rightly placed. Is r of I equal to I plus 1? No, it is not, right? R of I is what? 4. And I is 0, 0 plus 1. Okay. So no, it is not rightly placed. This 4 is not rightly placed. So its right place is this particular position, right? So what we're going to do? We're going to move this element, or we're going to swap this 1 and 4. So it is going to be what? 1, 3, 2, and 4. This will be the state now. Okay. Now our pointer is still here, right? At the 0th location, 0, 1, 2, 3. So we will keep on sorting. We will keep on running the while loop until the correct element is placed here. So first of all, this four was not correctly placed, right? It was placed here. It was placed here. So we placed it at its right position. Okay, now whatever the swapped element, it may be the case that it is not yet correctly placed. It would have been 2 here, right? Maybe it would have been 2 here after swapping, right? So we have to move 2 to its right place. Okay, so we will keep on running the while loop, or we'll keep on running the cyclic sort until the element at this position is correctly placed. Okay, so here now we'll check here. Is r of I this condition. Is r of I equal to I plus 1? Yes, it is. It is at the correct position. So now we will move ahead. We'll come to this position. Okay. Now again we'll check. Is r of I equal to I plus 1? No. R of I is 3 and I plus 1 is what? I is 1, 1 plus 1, 2. No, it is not rightly placed. So we will swap with the right with its right place. Okay. So now 2 will be, so it will be like what? 1, 2, 3, and 4. We will still be here. Our pointer will still be here. We'll be checking whether now the new element which has come here on this position, is it rightly placed? Yes, it is rightly placed. So we'll move ahead. Now here we'll check, is it rightly placed? Yes, it is rightly placed. Arrow of I equal to I plus 1. Then we'll check for the next element. Yes, it is also rightly placed, and hence we'll be done. And finally, we'll check what is the swap count. Okay. So this is the intuition behind solving the problem. I think we'll go to the code. I think you'll understand better. Okay. Before going to the code, please subscribe to my channel, like the video. It will really be helpful to me, and also it will be motivating. Thank you so much. So let's quickly see the Java code followed by C++. So let's quickly write int n equal to r dot size. Okay. Now we'll take what? One swap count, okay, which will be 0. Now we will int I equal to 0, I less than, let's iterate through the array, okay. And then we are going to check if array of I equal to I plus 1, then the element is rightly placed. We did not do anything, just ignore it, just move ahead, Now, if it is not rightly placed, right? So what are we going to do? We are going to run cyclic sort, okay. Array of I, while array of I is not equal to I plus 1, we are going to say, right? Okay, now we are going to swap in temp equal to air dot get air of I minus 1. So what we are doing here is, I'll quickly explain. So this, with this statement, what we are doing here is, for example, initially this array was this, right? So what we want to do, sorry, the array was, yeah, it was like this. So what we are doing is, with this particular statement, in the temp variable, we are taking this element. We are taking this element, right? In the temp variable, we are taking this element, okay? And then what are we going to do? Air dot set, right? We want to set air of I minus 1 with air of, sorry, this is not array, right? This is not array. Dot get I want to do. Dot get I. Get I minus 1, air dot get I. Okay. And here also dot get I. So what we are doing with this second statement, right? We are doing with the second statement, we are placing 4 over here, right? At this particular location. That's what we are doing. We are swapping basically. We are placing 4 over here. And finally, what we're going to do? Air dot set I, okay, air dot set I temp basically. And what we are doing here is, we are placing temp over here, temp which holds 1, right? We are placing 1 over here. So now we have this state 1, 3, 2, 4. Along with this, we are also going to increment our swap count. Okay. Now we have done this. Now it may be the case that whatever element is placed here, right? 1. For example, now this array looks like this. Okay. And we are still here. So we're going to check. It may be the case that the element which is now newly placed, it may not be correctly placed. Okay. Up until now, it may be the case that it would have been 2 here. So we would run the cyclic sort again. Okay. We would run the cyclic sort again, but here it is 1. So hence, this while loop will break now. Okay, this while loop will break and we'll move on to the next element. Okay, and we'll move on to the next element. So finally, what to do? So finally, if swap count is equal to 2, or this array was already sorted, then in that case, we want to return true. If swap count is something else, right? We'll simply, if it is something else, we'll simply return false. Okay, now there's some problem. Yes, definitely. It is not array, not get I, right? We're going to do, let's run, let's see. It is all right. Here also, there's this issue, dot get I. Okay, let's submit it. Yes, the test cases are passed. Thanks for watching. I hope you've got the solution. Please subscribe to the channel, like the video. Let's quickly explain this, right? The time complexity. So here we are taking one for loop, which will take O of n. Now this while loop, there's another while loop, right? In worst case, it is going to take O of n. Okay, the overall time complexity is still going to be O of n. Why? Because in the worst case, if this while loop takes O of n, then this will be straightforward. Okay, we'll just ignore, we'll keep on, because the elements will be sorted. If this case, in the worst case, if it takes O of n time complexity, then the array will be sorted. Okay, we'll just continue, we'll just ignore basically. Okay, so thanks for watching. Let's quickly see the C++ code as well. Okay, so here's the C++ code, right? It's like, it's the same. It's the same. Nothing to explain here. I'll attach the code in the comment section, both the code Java and C++. Okay. Thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy, and a great day. Thank you so much.